This lecture we'll do a number of examples, kind of little questions using set operations. Okay, so what do we got here? Consider U the set of length 3 binary strings. I'm just going to count here. This is the 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. I knew because it's 2 to the 3. 2 by 2 by 2, 8. Let A be the set of binary strings with exactly 2 ones, and let B be the set of binary strings that begin and end with a 1. Investigate if not A and B is the same as not A or not B. Okay, so I'm calling this AND all the time and this OR. Okay, so note that A has exactly 2 ones. So if I just go through them, no, 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 yes, it's there. No, yes, it's there. Yes, no, that is 3 ones. So that's A. It's okay. And B starts and ends with a 1. So it has to be 1 and 1 and either a 0 or 1 in the middle. Okay, so we're going to investigate if these two sets are the same. So this is just an investigation. It's not a proof or anything. We'll just investigate. So we'll find out what this is and find out what this is, and then we'll just look at them and see are they the same thing. So we should build this up. So first of all, find A and B. A and B, or A intersection B. So here you probably go through each, well, it has to be in both of them, so maybe pick the smaller set and say, is it in there? So is 1, 0, 1 in there? Yes. And is 1, 1, 1 in there? No. So the only element that's in A and in B, in both A and B, is 1, 0, 1. So now that's A and B, A intersection B. Now let's do the not of that. So everything that's not in there. So we'll go through the ambient set, the universal set, the ambient set. So this is not in this, 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 this is in this. So this is in A and B, so it's not in not A and B, so it's not in here. 1, 1, 0 is not in here, so it goes in here, and 1, 1, 1 is not in A and B, so it goes in here. So as well, we can think about this not A and B as the same as the universal set take away A and B. Now this is a little bit dodgy here, because is it not A intersection B, or is it there's a bit of an issue here. So any kind of confusion, and you'll see this in your programming, you're going to need some brackets. Yeah. So essentially take everything in U and take away anything in there. So just this set, take out the 1, 0, 1, and you get this set here. So that's not A and B. Done. So now let's investigate not A or not B, not A union not B. So we should find not A first, then not B, and then we will take the union of them. So if we look at not A, so these are the things that are not in A, so we just go through the ambient set and we just get all the things that are not in A. That shouldn't be too hard. And not B, go through this and just kick out 1, 0, 1, so that's gone, and 1, 1, 1. So there'll be 6 elements left here. 1, 2, 3, 4, 5, 6. Okay. So the union is all the elements that are not A or in not B. And how I recommend that you write this is you write down everything that's in the first thing, which is in not A. So that'd be 0, 0, 0, 0, 0, 1, 0, 1, 0, 100, sorry, it's not 100, it's 1, 0, 0, and 1, 1, 1. And then what you also include is everything that you haven't listed yet. Now that's already been listed, that's already been listed, that's already been listed. 0, 1, 1 has not been listed. 100 has already been listed, and 1, 1, 0. This one. Now the question is this the same as not A and B? And if we just kind of eyeball it, so this is in the other one, this is in the other one, this is in the other one. 0, 1, 1, yeah. 100, sorry, 1, 0, 0, 1, 1, 1, and 1, 1, 0. Now here, by checking that everything here is in here, we've just shown that this is a subset of this. We should really check the other way around just to make sure. So 0, 0, 0, yeah. 0, 0, 1, yeah. 0, 1, 0, yeah. 0, 1, 1, yeah. 100, I keep saying 100, 100, 110, and finally 111. So that shows this is a subset of this is a subset of this, they have to be the same. So we can investigate and show that in fact not A or not B is the same as not A and B. So that's a kind of investigation question. Next question, illustrate using Venn diagrams that these are the same. So my opinion here would be that you draw a Venn diagram for this, draw a Venn diagram for this, and just look at them and see that they're the same. If I was to make these, I would do this in two goes. So this one, I would first make A union B, so that one is okay. So this is going to be A union B here. So I need a universal set, I need a set A, and a set B. And so all the elements that are in A or B. That's all, this is all A or in B. Okay, and the not that is everything that's not in there. It's obviously going to be the bit outside. Now I'm going to write this symbol here. Now this kind of means implies. If this is true, then this is true. If this is A or B, then from that, therefore, we get the not A or B. These laws that we're looking at here, where you've got a not over a union, turning in, and the not goes, but turns this into an intersection, and the one we saw previously, where you've got a not over an intersection, turning into two knots and a union, so it goes toggles essentially from intersection to union. These are what are called De Morgan's laws. So it's going to be everything outside there, so that'll be out here. Okay, now what we're going to do now is we're going to look at not A, not B. We might use two colors, and then we'll union them. I think that's what we're going to do. Or we could do maybe, yeah, we'll do actually two pictures. So we'll do not A, we'll do not B, and then we will intersect them and see do we get the same picture. So this is an illustration. Okay, so this is going to be not A, not B, therefore not A and not B. So all the time we have our universal ambient set. May as well draw these things. A, B, A, B, A, B. Okay, so not A. So we must, now one of the things we can start doing now is just kind of look at the regions, because they're all the different bits. And I'll put a dot in them and color in afterwards. So is this not A? No, this is A. Is this not A? No, this is A. What about this? Yes, this is not A, so this will be to be colored. Is this A? No. So if it's not in A, it's in not A. So these are the two regions to be colored. Not A, and maybe just to, in case you're not clear what I'm doing, let's draw this. So it's everything outside A, everything not in A. Right, similar story, let's do everything that's not in B. I suppose the easy way here is maybe to draw this around this and then just shade in everything that's left. Now the intersection is in both. It's probably difficult to look at the pictures and just find the intersection. So we'll maybe just note that there's only 4 regions, right? There's here, 1, 2, 3, 4. These are the 4 regions, and these are all we have to go. So is this bit out here, is this in not A? Yes. And is it in not B? Yes. So this is going to be colored. Okay. Remember, this is, it has to be in both. It's probably hard to intersect these, so we're going to have to talk about the and language. So take this bit. Is this in not A? No. And if it's not in not A, it can't be in both of them. So that's not there. What about this middle bit? Is this in not A? No. So this cannot be in the intersection. And finally, is this in not A? So this is not in not A, so this is okay. It's in this bit. But is it not B? No. So the only bit that works on both of them is the outside. And if you look, these are the same thing. So if we're kind of doing this black with a knot, you can see these are exactly the same thing. Does this really explain it? I'm not so sure. I mean, it's obvious. Okay, like this one should be actually easier. Like you've got everything that's in A, all the elements that are in A or B, and then you just knot it. Here's probably not so sure or clear whether they're the same. We'll talk about these De Morgan's laws a little bit more as we go. Okay, now this next question, it's just nasty. We're just it's nasty. We won't do that. So this is something that I'm going to say is difficult to follow, this bit here, but we're going to learn in a later section an easier way of doing this. So this is kind of tricky. Okay, here's a question. Use symbols to describe the shaded area. Okay, I'm going to give probably two ways of looking at this. Okay, so one way you could look at it, so there's two main ways, right? One is if you kind of just see it kind of quite easily. So for me, I kind of can see this. So what I can see is, but like, how can I teach you how to see it? I can't. It's just a question of you doing exercises. So, but I'll just show you what I see. So I see here, in this thing here is A or B. So all this. And I can see that it's the intersection of that with C. Now that's really just seeing the intersection. Alternatively, no, that's how I see it. I just write down the answer, right? So I can see it as, now I have to use brackets here because it's A or B intersection C. Okay, now that's just me writing down the answer, wasn't it? I mean, so that's no good. So in terms of teaching, the best teaching is for you to do the exercises and just do these yourself, but I'll give you an alternative thing what you can do. So here what you can do is you've got three regions, 1, 2, 3. And what you can do is for 1, 2, and 3, you can actually describe them. And then what you can do is union the three of them. So this is the alternative. So the first thing is, now I'll show you what is not really acceptable, is if you say, okay, region 1, it's A, not B, and C. So it's in A, it's not in B, it's in C. This is not appropriate symbols. What you want to say is that it's in A, and it's not in B, and it's in C. Let's see, so it's in A, yes, it's not in B, yes, and it's in C. So it's in A and not B and C. The second region is probably the easiest for us. It's in A, yes. It's in B, yes. And it's in C, yes. And the third region, is it in A? No. And is it in B? Yes. Is it in C? Yes. And we can form the union of all three of those. I think it's easier if you just see this, but it mightn't be possible. So let's write down A and not B and C. You definitely need the brackets here because otherwise it's not clear. Like, because if I do the intersection first or the union first, they're different things. So it's very important that you do the brackets. A intersection B intersection C, or not A intersection B intersection C. So these are the possibilities. Yeah, so these are basically the two ways. Either you see it, and just other ways you could see it. I mean, you could, like another thing you could see is if you put 1 and 2 together, that is A intersection C, and put 2 and 3 together, that's B intersection C, and you could union those. So I'll write that. That's another thing you might see. So it's A intersection C, or B intersection C. And actually what we have here is set identities. So you can kind of multiply this out, A and C, or B and C. How these are related, how this is the same as this is probably a bit more complicated. You'll need what we'll do a little bit later, which is truth tables. Okay, but here's 3 approaches. You might have another one of your own. Personally, I can't see another way of doing it, but in theory there's probably infinite is probably pushing it, but there's lots of ways of doing it. Okay, an exam question. Now I'm not so sure about your assessments, but you might have questions like this. So suppose A is the set containing 1, 2, 3, 4, 5, B is the set containing 3, 4, 5, 6, 7, and the ambient set is the set from 1 to 8. So let's find these. So again, we've done questions like this, build it up slowly. So first, if we're going to work on the left-hand side here, find A and B. So how are we going to do this? Maybe we go through A and then we just look over, is it in B? A is 1 there? No. 2 there? No. 3, 4, 5? Yes. And we don't have to look at 6 or 7 because it has to be in A and in B. So what you can do is you can go through everything in A and just double check, is it in B as well? And only 3, 4, 5 are. And now we find the complement of this. So this is everything that's from 1 to 8, but not this. So that'll give us 1 and 2, yes. 3, 4, 5 don't go in this because they are there. Not A and B is A and B. Or A and B is not A and B. We also have 6, 7, 8 though. Okay, now I'm going on about De Morgan's law. Have I actually written it down somewhere? Maybe not. But anyway, these two are equal by De Morgan's law. But alternatively, let's find not A and not B. So not A is, so 1 to 5 is in A, 6, 7, 8 is not in A. And not B, so 1 to 2 are not in B. 3 to 7 are in B, and 8 is not in B. And then we form the union, and my recommendation for a union is it's all the things that are in this or in this. So list everything here, and if there's anything left over, just 1 and 2, put them in as well. I don't have to put in 8 again because I've already got it. And in sets, order does not matter. So 1, 2, 6, 7, 8, 1, 2, 6, 7, 8, they're the same thing. Sorry, this should be, now the way I've written it, I can't fit in not A or not B, but one of the laws we're going to learn about is when you're doing unions and intersections, the order doesn't matter, so it's the same as this. So find these, yeah. So I think the clever way to do this is to find this and then just say, by De Morgan's law, this is the same thing. Okay. So this one is an investigation. Now, this is tricky. You can look at it and go, oh, like, could there be weird scenarios where these are actually the same? I don't know. So I'm going to recommend using Venn diagrams here. Okay. So the Venn diagrams, we're going to find not A and not B. Set A, set B. So like you're watching these videos, you have to understand that your real learning is going to come when you actually do the exercises. So it's very, very important that you do the exercise. My recommendation is you spend 7 hours a week between lectures and exercise. That really should be enough. If you can't quite do that, okay, but like you really have to prioritize your maths. So the not A is everything that's not in A, so it's outside A. That, and then not in B is outside B. Yeah, I mean, maybe that's the way to think about not B is outside B. Certainly when you're thinking in terms of Venn diagram, not B is outside B. Okay, now what is the intersection? Now again, we're into the difficult thing. It's hard to just look at those, but what you can do is there's only 4 sectors. So So just go through both of them. We're looking at not A intersection not B. Let's use this symbol, this therefore symbol. Universal set. Remember as well, all the time you can pause me. If I'm going too fast, you can pause me, that's no problem. Something you can't do in a lecture. Okay, so let's go through each region. Is this in not A and not B? Yes, yes. So this bit gets shaded. The outside is what I mean there. Now that's one thing some people get confused about, think this is the universal set. No, everything is in the universal set, in the ambient set. This is the stuff that's not in A and not in B. What about this? Well, no, because it's not shaded. No, because it's not shaded. Yes, so far, but if you look over here, it's not shaded. So this is all it is. So this is not A and not B. Now we're going to look at A intersection B, because we're looking at not A intersection B. So first find A intersection B, build it up. Like you can try and do it in one go, but I don't know, I don't see the value. You might get a bit confused. Maybe just build it up. It doesn't take that long. So all the things that are in A and in B, well, that's this little bit here. Okay. And yeah, so this is in A, but it's not in B. This is in B, but not in A. This is in neither. This is in A and B. And I will do the complement. So everything that is not that. So we're going to go outside that. So outside the intersection. Let's see what we get. And it's obviously not the same as this. These are different things, because for example, things that are in A and not B are in this, but they're not in this. This is, does it say investigate? Ugh. So the conclusion of our investigations is that not A and B is not the same as not A and not B. In fact, this thing is not A or not B. So we can see these sets are not equal. Indeed, for A equal to this county starting with C and B county starting with W, not C and not W, you get a load of counties, but the only thing that's so C and W, so that starts with C, contains W, is just Carlo. So not Carlo is like 31 counties. This is not 31 counties. These sets are not equal. They're both big sets actually. If you look at it, like this is a fairly big set, this is a fairly big set, this is big, this is 31, but they're not equal. Okay.